Hello, welcome to the 11.5 notes on areas of circles and sectors. So the first thing that we're going to talk about is the area of a circle. In order to find the area of a circle, you need to only know the radius of the circle, and the formula is area equals pi r squared, which is weird because the pies I've seen have all been circular in shape. Just kidding. All right, first example, we're going to find the area of a circle whose radius is 2.5 centimeters. Pretty straightforward. We just plug that into the formula, so it's going to be area equals pi times 2.5, and then we square that value. Okay, so when you do that, you're going to get that the area is equal to 6.25 pi centimeters squared, which the approximate answer then would be 19.63 centimeters squared. All right, so if it asks you for the exact answer, remember you will never press that pi button on your calculator. If it asks for the approximate, you will press that button and get the decimal equivalent. One thing I want to mention here is that students often do get confused between the two formulas that go with circles, circumference and area. So I always just tell them, remember the area, the unit is always going to be a square unit. So it's the formula that has a square in it, is the area formula, because the units are squared. All right, next example here says find the diameter of a circle that has an area of 113.1 millimeters squared. So again, we're going to use area equals pi r squared and plug in what we know. So we were given that the area is 113.1, so I plug that in for area equals pi r squared. Okay, we have to divide both sides by pi here. And you get that the radius squared is approximately 36.00 millimeters. To get r by itself, we square root both sides, and you get that the radius is about, that's a cute one, 6 millimeters. But they didn't ask me to find the radius, they asked me to find the diameter. So I didn't waste your time. Remember that the relationship between radius and diameter is the diameter is twice the radius, so we get the diameter is going to be 12 millimeters since it is twice the radius. Okay, so that brings us to the second part of today's notes, which is finding the area of a sector of a circle. A sector, again, like we said before, is like a piece of, let's say, pie or a piece of a pizza. It's how big this piece right here would be. The way that we're going to set this up is going to be a proportion, very similar to how it was with sector lengths. When we were just looking for the edge, we're going to set up a proportion where we're going to have the degrees, and then we're going to have, instead of lengths on the right side, we're going to have areas. So within our proportion, I'm going to set up our proportion here. Just like with the length of the sector, here we're going to have the part. And on the bottom, we're going to have the whole circle. So numerators is going to be the sector pieces, the bottom is going to be the whole circle. Now there are certain things that are not going to change here. The sector part degree measures is going to change from problem to problem. The whole circle degree measures is always the same. It's going to be 360 degrees. The area of the sector is going to change from problem to problem, but the area of the whole circle is always going to be the same. It's pi r squared. Okay, that's our circle area. Okay, so let's do example 3 where we're going to use this information. So here we want to calculate the areas of these sectors. Now notice on my screen here I have two different colors. I have the blue piece of the circle and I have the red piece of the circle. So let's find the red sector first. I'm going to set up my proportion. Something over something equals something over something. The bottom of the left side, because it's degrees, is always 360. It's the entire circle. And the bottom on the right side is going to be pi r squared. It's the area. So pi, and notice that the radius of this circle is 8, so it's going to be pi times 8 squared. Now, we have the degree measure of the sector, so that's 70. We don't know the area. Let's call it x. As with any proportion, I'm going to solve this by cross multiplying. So if I do 360 times x, I get 360x. And now when I do the other side, I'm going to have 70 times 8 squared, which is 64, and then I'm just going to bring the pi along. I'm not pressing pi on my calculator until the very end, and even then maybe I won't if I want an exact answer. Pi is just going to be there. Alright, to get x alone, divide both sides by 360. And now if you want an exact answer on your calculator, all you're going to do is 4,480, divide that by 360. Your calculator will give you a decimal answer. Convert that to fraction by pressing math frac, and you get 112 over 9, and then the pi just hangs out at the end. If I want to know what this is approximately, I would press the pi button on my calculator, and it gives me the approximate answer of 39.10, and they didn't give me units, so I'm going to write units squared. Okay, let's do the same thing, but this time let's do it for the blue sector. So the blue sector, I'm also going to set up a proportion. So I get my proportion ready. The arc degree measure, if the red one was 270, I have to get the blue one. So remember that the two angles here have to add up to 360 because they form a full circle. So it would be 360 minus 70, which is 290. Full circle is still 360. We don't know the area of the sector, so I put x there, and then the area of the circle is pi times r squared. The radius is still the same. Let's cross multiply. We're going to get 360x equals, now we have 290 times pi times 64. That gives me 18,560, and then I just bring the pi along, divide both sides by 360. And now on your calculator, you're not going to press pi, you're just going to do 18,560 divided by 360. It will give you a decimal. Convert that to fraction form. It's going to be 464 over 9 pi, which is an approximate answer of 161.97, and that's units squared. Now you can always check your answer with these in a couple of different ways. We could find the area of the entire circle, this whole thing, by doing pi r squared. Whatever that number is, if we added these two answers, it should be the same. Secondly, another way I could have done this problem is once I found the area of the red sector here, instead of setting up this whole proportion and doing all this for the blue sector, what I could have done is taken the area of the circle by doing pi r squared and subtracting the area of the red sector. So there's a few ways you could do this. I personally would do this way, just because it's faster to do pi r squared minus 39.10 or even minus 112 over 9 pi. Alright, for example 4, we want to find the area of circle V. So this is just like the problems with the length, where they didn't ask you for the area of the sector or the length of the sector. They gave you the length around the circle or whatever, but you're still going to plug into the proportion just like we've been doing. So on the left side is all angles, so sector angle degree measure is 40, full circle is 360. In the numerator on the right side, we put the area of the sector, which they gave us is 35 meters squared, and on the bottom is the area of the circle, so pi r squared. If you write an a in the denominator, that's fine, you'll still get the same answer. Alright, let's cross multiply. I'm going to get 40 times pi r squared is just 40 pi r squared. And then 360 times 35 gives me 12,600. Let's divide both sides by 40. And we get pi r squared equals 315. Now at this point you may want to keep going. You're going to want to divide by pi, then take the square root of both sides, but that's all unnecessary work because we want to find the area of the circle. The area of a circle is pi r squared. So if we were to divide by pi, square root the r, we would just be having to then plug it back in. So this is the area of the circle. Now if they asked me for the radius of the circle, yes, I would have to keep going for sure because I want to get what r is. All right, last example that we're going to do together is example 5. Now, what we're going to be finding in this example is the total area of this piece of a basketball court. I don't know what it's called. I know they shoot free throws from right here, the guy would stand, but what this name is, I don't know. But we're going to find that total area. So notice that I shaded them 2 different colors. Why? Because I have 2 different shapes. I have a rectangle, and then on top of this rectangle, I have not a circle, but half a circle, which happens to be called a semicircle. So to find the total area, I have to find the area of the circle plus the area of that semicircle. So the area of a circle, as we all know, is base times height. And then a semicircle, I'm going to want you guys to figure out on your own how to find the area of the semicircle. So let's take a look at this picture here on the right, which gives us a ton of different dimensions of a basketball court. We want to find this piece, this rectangle plus this semicircle. So let's go ahead and find the area of the rectangle. Base times height. The base of this rectangle is 18 feet, 10 inches, times the height, which is 12 inches. Just kidding, 12 feet. So hopefully right away you realize something's not right here with the base because we have 2 different units. We have feet and inches, so we're going to have to convert. Now 10 inches doesn't translate nicely into the amount of feet, so what I'm going to do instead is I'm going to turn the feet into inches. So the way I would do that is you take 18 times 12. That's going to give us how many inches 18 feet is, and then we're going to add the 10 inches that's also there, and then we're going to do the same thing for 12 feet. 12 feet times 12 inches would give us how many inches are in 12 feet. So doing 18 times 12 and then adding 10 to it, I get 226. And then because I'm finding the area, I'm going to multiply that by 144, giving me a grand total of 32,544 inches squared for the rectangular portion. Alright, so now I want you guys to find the area of the semicircle, and then tomorrow to class bring me, and I'm going to be checking when I check in your notes, bring the total area for that entire section of the basketball court. Okay, so that's it for today. Thank you so much for watching. Bye.